So you guys have been started looking at vectors, and not just vectors, but you guys started looking at vectors and components. And I sort of showed you a simulation type thing before. And vectors sometimes go straight sideways, sometimes they go up and down, but often they go at angles. And when they go at angles, we need to break them apart into pieces that are easier to work with. And it's not a complicated idea. Basically, all you're doing is you're asking yourself, how far does the vector go sideways and how far does it go up and down? That's basically the idea behind it. It's just that simple. So let's take a really, but this is about as simple as it gets. Maybe, you got something like this. Maybe it's 14. We're just making stuff up as we go along here. You got a vector going straight to the right, and it's got a length of 14. Well, the x component for this guy would be 14, and positive 14 because it's going to the right. Its y component would be 0. The x component is how far sideways. The y component is how far up and down. And that's basically it. What if you had something like this? Maybe it is 8 long. Well, the x component for that one, well, it's not going sideways at all. There's no sideways part to it. So the sideways part to it would be 0. And the y component would be 8. But it's not just 8 because it's going down. It would be negative 8. So that's about as easy as it gets. Okay, how far sideways, how far up and down, just that simple. But now what if we took these two vectors? Let's take this guy right here. I'm going to copy that one and paste it. There we go. And then I am going to do the exact same thing for this guy over here. Okay, I'm going to copy and paste it. And he's over there. Oh, I want transparent selection. There we go, it's better. Okay, something like this. Okay. Now, those two vectors together would give me something like this. Okay, so what if I started instead with this sort of like lime green looking thing? Well, I can't use it like that. What I would do is I would break it apart into its components. I'd ask myself, how far is that vector going side to side? How far is it going up and down? Well, for this vector right here, for this vector right there, the x component would be 14 because it's going 14 sideways just like it was up here. The y component for that vector would be minus 8, the same way it's going 8 down over there. And there's, of course, our 8 right there. And that's the basic idea behind it. Sometimes you start with sideways, start up and down, super easy. But if they're an angle, what we want to do is we want to turn them into a triangle to make things easier. So if I actually just started with that lime green looking thing, something like this, maybe I'd started with that, the first thing I would do is I would actually go to where I started from. I'd actually make a little x-axis all the way across until I get to the end, and then I would drop it straight down, and I would then make those two sides. I would then measure them to, basic ways, just using a ruler. Measure how long this is. Apparently it's supposed to be 14. You'd measure how long this is. Apparently it's 8. And then you'd have your components. Okay, it's just that simple. Okay, so sometimes you just got a vector sitting there, just grab a ruler, turn it into a triangle. And, we use right triangles because they're easier. Measure how far it goes sideways. Measure how far it goes up and down. If it's going to the right, it's positive. If it's going to the left, it's negative. Up, positive, down, negative. It's actually a really simple idea. Okay, but again, if it's not going, sideways is really easy. Straight up and down, really easy. But if it's an angle, we turn it into a right triangle in order to find the easier sides to actually work with. Okay, it takes something a little bit different. Suppose got something that looks like, I got a vector that looks something like this. Okay, and like that. Okay, I can't really use it in the way it is right now. So what I would do is I'd go to the beginning, over here where it starts. I always like to start with an x-axis first. I would draw that all the way across, and then I would draw a vertical one, something like this, make a little right triangle out of it, and then I would literally grab a ruler and measure it. Okay, so maybe this is 3.5 centimeters. Maybe this is 4.4 centimeters. So I measured it, and then for my x component, my y component, well, how far is it going sideways? Well, it's going 3.5 sideways, so 3.5. But since it's going left, that would be negative 3.5. My vector is going up, so my y component is 4.4, and I would leave it as positive because it's going up, and that's the basic idea behind it. Okay, so it's all about, you know, how far sideways, how far up and down. That's the basic idea behind components. Okay, so let's clean this up a little bit, and we'll start with a new screen, and then we'll sort of show you how this type of stuff works as well. Okay, so let's start with a vector. Let's actually start with two vectors. Okay. So I'm just going to draw one going straight across, something like this. And then I'm going to draw another one, maybe something like this. Okay, so something like that. Okay, we're just going to make up some values so we can move along here. So the first one's nice and simple because it is just going straight across. It's really easy. Okay, the second one's at an angle. So again, I'd start wherever it started from. I'll make my little sideways, and then I'm going to go up to meet it to make a right triangle. Now let's just make up some values here. Suppose the first one up there, suppose that's 10, and let's say this over here is 3, and that's going to be 4, something like this. Okay, and I would just measure them, just straight up measuring them, 3 centimeters, 4 centimeters, 10 centimeters, so something like this. Okay, so now what if I wanted to take these vectors and I wanted to add those vectors together? Well, it's actually really, really simple. I've got my x components and my y components. For this guy over here, I'm going to move this over just a little bit. Okay. For this guy over here, the x component is 10. The y component is 0 because it's not going up and down at all. Here, the x component is 3 and the y component is 4. It's going to the right, positive. Going up, positive. All right. Now, what if I want to add them together? Well, it's really simple. Okay. I want to know my total x and my total y. I'm going to take my x's, I'm going to put them together. I had an x component here, I've got an x component there, I'm just going to put them together. My total x component would be 13. I want my total y component. I've got 0 there, I've got 4 there, my total y component is 4. So I find my total x and I find my total y, and then what you do is you take these two totals right here, and these two totals, you actually take them to actually make a brand new triangle. Okay, so this sort of lays out the steps. The first thing you do is you find the components. Done. The second thing you do is you find the total x and you find the total y. Done. The third thing you do is you make a new triangle out of those. So I had a total x of 13. So I'm going to draw a line that is 13 long. My y component was 4. So I'm going to draw a line going up, which is 4 long, something like this. Now that's just a rough sketch, but that's the general idea. So then I need to know my answer, so to speak. My answer will go from the beginning all the way to the end. So let's draw a little nub there, and it would do something like this, from beginning to end. And just like when you guys were drawing them a couple of videos ago, you would just measure how long it is, and then measure the angle, and you'd have your answer. Okay, so we've got the, oh, there's the 4, didn't leave that 4 in there, there we go. It's probably around 14 long or so, something like that. So that's generally how this works. Number one, you break them into components, you find the total x, you find the total y, and then you make a new triangle out of it, which leads to the last part, and that's just solve for this, what's the resultant. And that's the basic idea behind putting vectors together with components. Okay, find the components, put the total x together, put the total y together, use those totals to make a new triangle, and then you got your answer. So of course the initial part of find the components is actually pretty important, because if you can't get that, or you mess up with that, everything else sort of doesn't work out very well. So let's practice just finding components in different scenarios, and then we can worry about how to actually piece things together, and we'll go over that again. Okay, so let's clean this up a little bit. Let's get rid of this. All right, so we are just going to start a little bit and practice a little bit at just finding good old-fashioned components. Okay, now we've done the straight, sideways, up and down type stuff. Let's do some other type of vector type stuff that we can have. For example, what if we have 35 at 40 degrees? So we've looked at different ways that vectors are actually described, and one of them is to have stuff like this using compass directions. Well, not compass direction, but angle directions. So this is 35 at 40 degrees. So first of all, I'm going to sketch it out. I'm going to draw a little axis system to help myself out. Now remember that 0 degrees is straight to the right. So, and then positive angles like 40 degrees, I'm going to swing it up 40 degrees up. So if I draw what this should look like, this would be 0 degrees. I don't want 0 degrees, I want 40 degrees. I'm going to swing it up 40 degrees, which is probably somewhere around there. So there's my 40 degrees right there, and this is 35, not degrees. This is 35, whatever, centimeters, forces, which would be newtons, whatever you want, doesn't matter. So I want to know the components for this vector. So I can't use it the way it is. So I want to find out how far sideways, how far up and down. So I'm going to start by going over where the actual vector starts, which of course is right here. I'm going to draw a line across and then go up, and it makes a right triangle. Now this is where the trig can kick in nicely, and you can get nice exact values because you got 35, you've got the 40. This is where your cosine sine functions really kick in. That's why you want to practice that type of stuff before and come with your math background with your trig. So if I'm going to solve for how the sides, this side down here, this is the adjacent to the angle, this is opposite. So the adjacent, typically you're looking at the cosine function, and for opposite you're typically looking at the sine function. So if I use my trig, if I do 35 cos of 40, this will give me my x component, and if I do 35 sine of 40, that'll give me a y component. Okay, so if I do my 35 cos of 40 degrees, this tells me it's 26.8. So this side over here is 26.8 long. And if I do a 35 sine 40, then I've got around 22.5. So this side right here is 22.5 right there. And this is basic trig. That's all this is. Okay, so in terms of components, this would be my x component, that would be my y component. There's my x component right there, there's my y component right there. It's going 26.8 sideways, it's going 22.5 up. Okay, just that simple. Just got to remember your basic trigonometry type stuff, okay, which is basic grade 10 math. Okay, so that's where your trig can really kick in, and you can solve for components. And when you do it this way, if you're measuring, there's always error, and there's, variation. This type of stuff, everybody should end up with nice, consistent, accurate answers. Okay, so let's try a different one. Okay, suppose we've got 720 at 125 degrees. Okay, so 720 at 125 degrees. So first I'm going to do is I'm just going to start with a sketch. It's always a good idea to sketch the vector so you have an idea what's going on. Okay, so first things first, my vector is, it's not going to the right, that's 0 degrees. Straight up would be 125 degrees. I want to go a little bit further. So 125 is probably around there, give or take a little bit. So that angle right there is 125 degrees. Okay. Now for this one, again, I'm going to break it apart into components. Now what I highly, highly, highly recommend is try and use smaller angles rather than big ones. So when I start this thing, I want to turn this to a right triangle. I'm actually going to go to the left, and then I'm going to go up. And you can use the 125 if you want to. I don't like using the 125. I'd much rather use the little 55 that's in there. Okay, I find it a lot easier using the 55 than the 125. I find it a lot easier using smaller angles that I can visualize a lot better. Okay, now I know this is 720 long. I know the angle there is 55 degrees. So again, I'm going to use cos and I'm going to use sine in order to find my x and y component. So to find my x component, I'm going to do 720 and use the cosine function of 55. For my y component, I'm going to do 720 times the sine function of my 55 in order to find out how far sideways and how far up and down. So if I do 720 cos of 55, I will get, well, we'll round up, 413. If I do 720 sine of 55, I will get about 590. And there's my x component, my y component. And if you use the 125 degrees, you'll end up with the exact same values, except for your positive negatives will kick in. Because when I look at this now, if I look at this, my x component, I got 413, which is fine. So this is 413. But since it's going to the left, it's not positive 14 or 413. It's got to be negative because it's going towards the left. My y component was 590, so 590, and it's going up, which is fine. So it can stay as 590. So my x component would be negative 413. My y component would be 590. Okay, and that's it. So again, just breaking apart a triangle. Okay, so let's try something else. What about compass directions? What if we have 85 at 20 degrees east of south? Maybe something like this. Okay, well, let's sort of piece things together. So first thing I'm going to do is I'm going to draw myself a little reference here to help me visualize. Okay, I am going to draw a vector here. Okay, so it says 20 degrees east of south. So I'm actually going to start by going south. Okay, so straight down to be south. Now I want to go 20 degrees east of it. So I'm going to swing it east about 20 degrees, which looks something like this. Doesn't have to be super accurate. All I need is a general idea of what's going on. So that would be 20 degrees in there, nice and small. There's my 20 degrees. Okay, so I want to break this thing apart into how far sideways and how far up and down. So same as before, I'm going to start by drawing a triangle. And I'm going to start, this is where it started from. I'm going to go sideways first. So I'm going to go to the right. And then I'm going to go straight down to make a little right triangle. Now the same way in the green one, I didn't want to use the 125. I don't want to use the 20 degrees. I want to use the 70 degrees. And this is the other key thing. Okay, big recommendation, let's clean it up a little bit. Okay, you want to try and use angles to the x-axis. Okay, and there's reasons for it. I just highly recommend it. We'll get to later on why possibly. I highly recommend don't use the 20, use the 70. Okay, it's just going to make things a lot more consistent, a lot easier for you. Okay, so I'm going to use that 70 degrees in there, and this was 85 long. So if I want an x and y component, my x component, I'm going to do 85 cos of the 70. Y, I'm going to do 85 sine of the 70. I'm going to find my two values. Okay, so if I do 85 cos of 70, should get around, we're just going to round off, around 29. And if I do 85 sine of 70, I'm going to get around 80. So now I'm going to look at my picture. Okay, it's going to the right. So my x component should be positive, so 29 is fine. It's going down though, so my y component shouldn't be 80, it should be negative 80 because it's going down. So I'm going to throw the little negative in front of the 80 there, and then we're all good to go. Now, sometimes, maybe you switch these values around. If you have those reversed, well, that's what happens if you would use the 20 instead of the 70. So sometimes when you get your values at the end, you just got to look at it. Does it make sense for, especially in this question, is the x bigger or is the y bigger? Obviously, the y component should be bigger than the x component. So when you do it and it's not, well, maybe you just picked the wrong angle. Use the 20 instead of the 70 by mistake. Maybe you switched your trig functions by mistake. So when you get your answers, just look at the picture. Does it make sense that this one's bigger than that one's smaller than that one? And then also throw in your positives and negatives. So clean up a lot of little mistakes and errors and that type of stuff. Now, the other thing that kicks in is, we had compass directions over here. So some people say, well, what happened to the compass directions? Well, what some people would do is they would say 29 going east. Some people would say it's 80 going south. I don't really do that. I just like the positives and negatives, because as you continue with this stuff and actually use it, it's the positives and negatives that are going to be a lot more useful than anything else. Okay, so this is a little bit more practice with components. Okay, so let's do a little bit more and show how we can put things together a little bit, and going back to the 4 steps I showed you before. All right, so we got 2 vectors. We got 35 at 45 degrees, and I've got 50 at 160 degrees. And what we're going to do is we are going to add these vectors together to get an overall answer. And we're going to just go back to those 4 steps I briefly showed you before. So the first thing I'm going to do is just one vector at a time. I'm going to break these guys apart. I want their x components and I want their y components. The first thing I'm going to do, and let's lay out the steps again. The first thing I'm going to do is I want to know the components. So I'm going to break them up. I'm going to make triangles out of them. Same thing we did before. So this guy right here, that's where I started from. I'm going to draw my x-axis first, then my y, and I'm going to break that guy apart. I'll do the same thing to this guy. I'm going to take this one, I'm going to make an x-axis, and then a vertical one. I'm going to break that guy apart as well. Okay, so for this guy right here, 45 is nice because I know the components are going to be equal to each other. So I'm going to do, I'll do my 35 cos of 45 degrees, and I can get my components. So if I do 35 cos 45, I get 24.7. So that's my x component. There you go. X component is going to be 24.7. So that's 24.7. It's a 45 degrees. So I know the 2 sides of my triangle are going to be equal to each other. So I know my y component is also going to be 24.7. So that's kind of nice. Okay. It's going to the right. X is positive. It's going up. Y is positive. So that one's all taken care of. All right, my second vector, I've got 50 at 160. So it was 160 degrees wrapped all the way around. I don't want to use the 160. I don't like that. I'd much rather use the 20 degrees that is in there. Okay, so for this guy over here, my x component is going to be 50 cos 20 degrees, and my y component is going to be 50 sine 20 degrees. Okay, so I'm going to do 50 cos 20. Actually pretty big, and it is. We're looking at 47.0, and I'm going to do the 50 sine 20 degrees, and we're looking at 17.1. Okay, so let me check my positive negatives and stuff like that. This is 47.0. This is 17.1. Okay, so my x component, well, my vector is going towards the left, so I should make that negative. My y component is going up, so that's fine the way it is. Okay, so first step done. My components are all broken apart. All right, so step 2. Step 2 is I want my total x and total y. All right, now to do this, a really common thing to do is a little chart type structure. A lot of physics type people, and especially people learning how to do this type of stuff, will use a chart. And it looks something like this. It's a little XY chart. And it's really simple. What we're going to do is we're going to take the x components and the y components and put them in the chart. So I go to my first vector, and the first vector had an x component of 24.7. So I'm going to put that on my chart, 24.7. My second vector had an x component of negative 47, so I'm going to put that, oops, wrong place, right there. Just erase that there. Okay, so I've got my 2 x's in the x column. Now for my y component, my first vector had a y component of 24.7, and my second one had a y component of 17.1. So all the x's in one column, all the y's in another column. So I want the total. So it's really simple. I'm going to add these guys up. I want to take my two x components. I've got 24.7 and minus 47. I'm going to add them up. And that gives me a total x of minus 22.3. Do the same thing with my y's. I'm going to add up both my y's, my 24.7 and my 17.1. If I add them together, I will get 41.8. Okay, so there's my total x's and there's my total y's. And this is where the third step came in. I want to use those to make a new triangle. So that's step number 4. Let's go with green. So step number 3, I want to make a brand new right triangle using my totals. So first things first, I'm going to draw them. So my total x component was minus 22.3. So I'm going to draw a line that represents 22.3 going towards the left. I'm going to need a little more room here. Move that over. There we go. And then, so I went 22.3 to the left. Okay, and then my y component is 41.8. So I'm going to draw a line going up like this, which is 41.8. And so when I do that, I'll go from beginning to end again. That makes my new triangle. Okay, and that's where I started from. Okay, so step number 1, break each one apart into its pieces. Number 2, you put those pieces back together and then use the totals to make a brand new triangle. And then that leads to step number 4, which is basically what is the answer. Now, there's different ways you can solve it. This is just a right triangle, and you're solving for the hypotenuse. Now, most people, what they will do is they would use Pythagoras to solve for the hypotenuse. So if you do the a squared plus b squared equals c squared, and you solve for the hypotenuse, you'll find this line is about 47.4. That's how long it is. Okay, and we also need the angle. Now, I would solve for this angle right here. It's nicely inside the triangle. I would solve for that angle right in there. And this where tan theta can come in really nicely because you have the opposite and the adjacent. And if you can use cosine sine if you want to, but if you messed up the hypotenuse, your angle is going to be wrong. So it's nicer to use more original values, and tan theta would work really, really nicely. So if we use tan theta, we find, well, we'll round off. This is around 62 degrees in there. Okay, so let's get the actual answer. Okay, so the length of the vector, I mean, that's the 47.4. So we've got the 47.4. Now, what angle is that? Well, I don't actually want to use this angle. This is where I started from, and I want to go from the positive x-axis, which is over here. So I actually want to wrap it around this way. So if this is 62 over here, this has to be 118 to add up to the 180. So my answer would be 47.4 at 118 degrees, and that would be those two vectors added together. Okay, so this looks like a lot of work. It's not hard math. It's all very basic trig and Pythagoras. It can get a little bit tedious, takes a little while, but once you get the hang of it, it gets quicker and quicker and quicker and quicker, and you'll blow through them really, really easily. But this is the basic idea. So 1, how far left and right, how far up and down for each one, get the x and y components, add up the x's, add up the y's, get the totals, use those totals to make a new triangle, and then just use your basic Pythagoras and probably tan theta to solve for the hypotenuse, and that's it. That's how you add the vectors together. Okay, so next we'll do a whole bunch more practice with this, because again, practicing the stuff and just keep on going through it is by far the best way to learn it.